Hello everyone, welcome to episode 4 of Qiskit Developer Coding Series presented by QuantumGrad. This series helps you prepare for this professional certification exam. I am Abha Naik and let's get started. Let us discuss the question 4 from the Pearson Sample test. This is the question. Given an empty quantum circuit object QC with 3 qubits and 3 classical bits, which one of these code fragments will create this circuit? You are provided with an empty quantum circuit object and you need to find out using which of the following code fragments in the options you will get this result. To begin with, we require to import the quantum circuit function from the Qiskit library. Just a quick reminder, you won't be able to use any code during the exam and you will have to know all these results well. Once we have imported the quantum circuit function from the Qiskit library, we can proceed to create our empty quantum circuit object, which is simply a quantum circuit with no operations, that is, no gates, measurements, and barriers. This is what our circuit looks like. To visualize it in a better way, we can use Matplotlib. This will be our result using Matplotlib. For those of you who are familiar with the various ways you can carry out measurement, you can skip to this timestamp. Now, let me explain the various ways to carry out measurement. One way is by using the measure_all function. To demonstrate this, I have a dummy circuit with all the properties of the quantum circuit in question. When we use the measure_all function for this dummy circuit, we see this output. As you will be able to see that the measure_all function, it adds a barrier across all the qubits, it measures all the qubits in the given quantum circuit, and it also adds additional classical bit register. So let us see what the measure_all function does when it only has qubits provided to it. So we again have a dummy circuit and we only have 3 qubits and no classical bits. When we use the measure_all function for this quantum circuit, we have this result. As you can see, the measure_all function has added a barrier across all the qubits, it has measured all of them, and it has also introduced an additional classical register. The second way you can go about measuring the qubits is by using the measure function. So for this, we have a quantum circuit with 3 qubits and 3 classical bits. When we use the measure function, we have to provide it with 2 parameters. The first parameter being the qubit and the second parameter being the classical bit. This is our result when we measure qubit 0 onto the classical bit 0. Alternatively, to give a command to measure multiple qubits at the same time, we can use the measure function, but here as parameters we have to provide 2 lists. The first list being the qubits that you want to measure and the second list being the classical bits onto which you want to measure your qubit. In this example, I am measuring the qubit 0 onto the classical bit 0 and qubit 2 onto the classical bit 2. We can also measure all the qubits at the same time using the measure function. Here we have to provide the measure function with 2 parameters. The first parameter being a list of all the qubits present in the quantum circuit, and the second list being being all the classical bits present in the quantum circuit. This is our result when we use the measure function on a quantum circuit with 3 qubits and 3 classical bits. I like to make a mention of this thing that the measure function requires a pre-written classical register. If we run this dummy circuit, which has only 3 qubits, and we provide the measure function with 2 lists, the first list being the number of qubits present in the quantum circuit and the second list being a list of classical bits. However, we have not provided the quantum circuit with any classical bits. So let us see how Qiskit responds to this. As you can see, Qiskit raises an error when we run this code. Why? Because we have not provided the quantum circuit with any classical parameter. So as we can see, measure requires a pre-written classical register. Let us see this example. We have a dummy circuit with 3 qubits and 3 classical bits. When we use measure and we provide it with parameters 0, 1 and 2, we get the following result. You see, Qiskit raises an error, that is, measure function takes 3 positional arguments but 4 were given. What does this mean is that the measure function, it took 2 parameters, that is the qubits and the classical bits, but we have provided it with 3 parameters. So the Qiskit code, it makes sense of maybe the 0 is the first qubit and 1 is the classical bit. However, it's all confused about 2. So we need to provide the measure function with just 2 parameters. The 2 parameters could be just the numbers or it could be 2 lists. We can also use the range function in order to carry out the measurement. That is, you provide the quantum circuit with a range with the parameter being the number of qubits that you want to measure. So here we have a quantum circuit with 3 qubits and 3 classical bits, and I want to measure all of them. So I have used the range function and provided the parameter as 3. So what do I get as the result? Is this. That is, I have measured all the qubits onto all the classical bits. Coming back to our question, let us see what the first option results in. The first option is qc.measure, and you have provided the measure function with 2 parameters. The first parameter being a list of the qubits and the second parameter being a list of classical bits. When we use this code fragment in our code, we get this result. As you can see, this result matches the diagram which is shown in the question. So this is the right answer. If in the exam you get this result, you just select it and move on to the next question. But since we are discussing the question here, I will also dwell some time discussing the other options. So let us see the second option, that is qc.measure, and you have provided the measure function with 3 parameters. The first parameter being a list with elements 0 and 0, second being a list with elements 1 and 1, and third being a list with elements 2 and 2. Let us see what we get as the result. You see, again, Qiskit raises this error that measure function takes only 3 positional arguments but 4 were given. Now positional arguments is something which is more dependent upon the definition of the measure function in Qiskit, but what it means to us is that we were supposed to provide the measure function with 2 parameters, however 3 were provided. So this is the wrong answer. What about option 3, that is qc.measure_all? Let us see what this results in. As we can see, option 3 provides us with a quantum circuit which is more or less similar to the quantum circuit that we require. However, as you can see, the quantum circuit in our question, it had no barriers and it only had one classical register. However, when we use measure_all function, we introduce an additional classical register and a barrier. So this is the wrong option. What about option 4? If you are very well aware of the measure function by now, you know that the measure function takes up only 2 parameters, and as you can see here, the measure function is provided with 3 parameters. So you can predict that this answer is wrong. And this is what we get as a result of running this piece of code.
Finally, we have solved the question. Do feel free to drop your doubts in the comment section below. If you found the video helpful, give it a thumbs up and subscribe to QuantumGrad for more such videos.